Sir, shall we start, sir?
Yes, sir, we can start, sir.
Yes, sir. Yes, sir. Very good afternoon, very good morning to all. Today, our eminent speaker, Dr. P. Karupanan, sir, Department of Electronics and Communication Engineering, MN NIT, Allahabad. Today, topic is recent research trends in active power line conditioners. Now, I would like to invite Devika Rani, madam. Shall we start, sir? Yes, sir, we can start, sir. Yes, sir. Yes, sir. Now, I would like to invite Mrs. Devika Rani, madam, to introduce our chief guest today.
Yes, sir. A very good morning, one and all. I take privilege to introduce this session speaker, Dr. Karupanan sir. Dr. Karupanan obtained BE in Electronics and Communication Engineering from Madurai Kamaraj University in 2004. He credibly completed his ME degree in VLSA Design from Anna University in 2007. He obtained his PhD from NIT Rourkela in 2012. Currently, he is a professor in the Department of Electronics and Communication Engineering, Motilal Nehru National Institute of Technology, Allahabad, Uttar Pradesh. He assumed this position in October 2012. He has been recognized as a highly motivated lecturer and research fellow who infuses positive attitude with innovative solutions for extreme frontiers. He has published more than 30 research articles and completed 3 funded research projects by TechUp, MNIT, BRNS, and CSIR respectively. His research specialization is focused on VLSA design, embedded systems, digital signal processing, digital image processing, soft computing techniques, PHZ antenna design, and applied electronics. Thank you, sir, for giving me this opportunity. Thank you. Sir, Karupanan,
thank you,
sir. Yes,
Professor Devika Rani, for introduction.
Yes, sir. Sir, now you can start the session, sir. Thank you, sir.
Okay, thank you. Happy morning, dear faculty members and the research scholar. I welcome you 1 week online faculty development program on research opportunities in electrical engineering, which is organized by Prashant V. Portluri Siddhartha Institute of Technology. I think today is the last day. Last 1 week, you learn a lot of information with some practical experience by the sharing their own knowledge or experience. You may gathered many information relevant to the electrical engineering. However, today we are going to make the final attempt to understand actually what the electrical engineer can do it in terms of we have 3 domains: to generate the power, transmit and distribute the power. And this topic mostly discussing about the distribution side, distribution with the customers. And we are the customer. Because of the customer needs, we need to generate the power. As we know, the Ministry of Power India, we are received some data, which is the power generation steam turbine we are using as the main resource to generate the power. Apart from there, we can have the gas turbine, hydro turbine, wind turbine, photovoltaic. So many techniques are available to generate the power. And second, to transmit the power, either 1 phase or 2 phase or 3 phase AC power system, like 2 wire or 3 wire power system, or in case of 3 phase AC power, we have the 3 phase 3 wire, 3 phase 4 wire system. Even DC system also transmitted like a DC 2 wire with a midpoint earthed connection and a DC 3 wire connection. And we are having the distribution, primary substation and customer substation. And this topic, active power line conditioner, is the instrument to improve the power and to provide the quality of power. It will ensure the quality of power. That is the topic. Here we have the three domain: AC to AC power converter, AC to DC, DC to DC, DC to AC power converter. So our practical appliance, we need to deal with all these power converter. However, mostly we can give the justification. AC to AC converter, a cyclo converter, it is having the limited application as we are the customer and the research topic. Because research topic, most of the papers, if you look at 50% of research articles based on DC to DC converter, DC to DC converter, remaining 50% DC to AC, that means inverter and chopper. This is, you can say, 90% of application or the engineers are working in this domain. And basically we can come up with one solution, that is the AC power converted to the DC power, and DC power again converted to the AC power for the practical appliance where the inverter is used. And this topic we are going to discuss about the power quality instrument, what are the problems are coming with the voltage or current source, so how to resolve. And I taken some research data, which is the recent data from our ministry side. From this, it's very prominently saying the central sector is having 98 megawatt power, 98,000 megawatt power, and the state sector by every state. In that is also Karnataka generating more power because of the resources. They have the more river and hydropower plant. It's having well established in the government Karnataka. And second, in Tamil Nadu, we are having the wind energy is a more dominant, and Gujarat also they are producing more renewable energy system like wind energy. They installed almost in every place. So it's having every state wise how much power is generated using the thermal power plant or nuclear power. Thermal power plant itself, we have mostly used the steam turbine using fossil fuel, but in India 51.6% power is generated by the gold mining, and then gas, diesel and lignite. And nuclear also we are installed, but the limitation of the nuclear power plant is very less. Biomass, geothermal, solar thermal energy, this all we are used. This all the data is available state sector, and private sector you can see the 50% their contribution. Private sector total power we need 3,95,000 megawatt power, and it's given the details which they installed. So here this website itself, it's given many number of data which we can make up to 2031 2022. That means up to the date they given the Central Electricity Authority. And second, here also we can find out thermal power plant, hydro, total power generation, and nuclear power plant, Bhutan implement. So this all it's given, but from this figure we can understand still we are using the thermal power plant. Like coal is the primary sector. Here it's given 52% we are using the megawatt power from the gold mining. And it's given again hydroelectricity, renewable energy sources, and so this all the data is given here in that state wise, which state having more power generation in terms of thermal and which year is installed. Every data is given here. Fine. So now we will going to discuss in the third domain, that is the distributor to the customer, where the customer having different kind of loads. Because of that we are having many kind of power quality problems. So how to resolve that problem we can discuss here. Now, before going to the particular topic, we just understand what is the research opportunities in electrical engineering. Before find out this session, we will understand what are the scope we can do in the research in this particular domain. Now, research means just reading and reviewing what is already present. If you want to become the best researcher, as per my own experience, 70% we need to study the literature review papers. 70% study, only 30% we need to make the mathematical modeling, like a proposed new modeling using mathematics or the high new topology, or even to simulate and to make the extra result proof everything. It's having only 30%, remaining 70% we need to read, and that also latest review papers. And IEEE transaction is the best one to understand the new concept and ideas how we are dealing. So that is the read and review. E is represent examine and evaluate. Whatever the concept is given by the researcher or scientist, we need to examine with our experiment. Then evaluate whether the data is applicable. If the data is applicable, whether it can be applicable to India. Even if it is applicable to India, what are the possibilities with our limited sources? Because we are working in some organization, maybe doing the part-time or full-time PhD, we have the limited resources. So with that limited resources, how we can focus our research to make, so that evaluation we can come up with the papers, and the systematic and scientific investigation from the studied materials. From that itself, we can make the systematic and scientific investigation to progress our research. And again, experiment and explore it. So do the experiment, whatever we are studied, it's not enough. Knowing the information is not enough, need to apply it. The applying, that is the practical experiment, we need to do the at least some prototype model. Or if it is the new artificial intelligence control algorithm, then we will take with this some nowadays many software computing algorithms are we are writing the, and that computing algorithm directly you can implement with many processors are available. With that dump the code and we can experiment partially, the at least the control algorithm is working. So that is the experiment, and then explore it. Then asking and analyzing. Whenever we are doing the experiment or studying any topic, the main thing we need to ask a question. Without asking why, what is the purpose, how it is implemented, how we can be do it, and how we can further do any analysis we can extend. So that is the asking, is a simple questioning and analyzing. And again, as we know the science concept, if you do number of times, if we are doing the number of times the same experiment, every time we should get the same result, or approximately is equal to the same concept. That's why we need to at least minimum 2 times we need to do it, that retest and re-examine the concept or the visualized whatever we got the result, and again consult and conclude whatever the limitation of our research work, where it can be applicable, and what are the cost effectiveness and merits and demerits of our own work. We need to be very aware. That is the consult and conclude. Then finally the H is represent hypothecation. So because we have the hypothecation knowledge, once we are coming up the research, then we can make the history maker. If we are coming with new research novelties or ideas, definitely we can change by our research concept. So that is the simple meaning of research. So this from my own experience, even you can frame your own method, what you are understanding. Research, again and again we are searching to do something new. We can formulate something new, or we can create something new. That's what it's called, the research. Now, outline of this particular topic and the presentation. What is the introduction and the part one, design of shunt active power line conditioner, then simulation result and the experiment result, conclusion, and some references. In electrical engineering, as we know, generally electrical engineers focused on the subject of generate the power, transmit the power, and distribute the power, then utilization as a customer of the electrical energy without any loss. The distribution system is a vital connection between the generation and utilization of the electrical power at a rated amplitude and frequency. It should be, as we know, in India we are having the 50 hertz frequency, some country having 60 hertz frequency. The frequency should be standard 50 hertz and 60 hertz frequency for the electrical components. And if we are going for the communication and generate different kind of signals or amplifier purpose, then it is coming to electronics field, that we need to generate the signal gigahertz frequency range. Suppose we are having the computer or the mobile, So what is the frequency? If you look at the operating frequency of the computer, it almost 2.77 gigahertz frequency range. So that is coming to the microelectronics. But in terms of power electronics, where it is almost 50 hertz standard unit or 60 hertz. So under rated amplitude, either it is the single phase or three phase, and it is based on that we have 215 volt or 220 volt to 230 volt as a single phase, and the three phase is having 415 volt to 440 volt amplitudes. We need to make the rated amplitude, which indicates the electrical power quality. But it is also expressed as the voltage in under versus current quality, reliability of service, and the quality of power supply, etc. And power poor power quality sources are raised from two categories. One is the non-linear load, or the electrical components and the equipments. Most of the electrical components itself, we can say it is the non-linear load. And the second, subsystem of transmission and distribution system. Mostly the service provider always provide the quality of power. Otherwise, we won't be happy to purchase from the government, because we are paying the money to get the electricity. And the subsystem of transmission and distribution system also introduce the voltage quality problem, voltage or current quality problems, but that is very shortage. As we know, in agriculture field, mostly we have the experience in the daytime and around 12 o'clock to that daytime very peak heat time. Most of the electric agriculture motor will be burn out, or some fuse will be happen because of the non-sufficient power. That time almost all the motor is running due to the heat, the electricity which is coming to the power line, we are not getting the sufficient power. Because of that, either it is a sort some problem may be happen when we are having the agriculture load, then you can easily understand in the during time. But mostly 90% the subsystem of transmission and distribution system won't create the problem. Most of the problem is non-linear load, you can justify here. And the quality degradation of electric power, such as impulses, notches, voltage sag, well voltage and current unbalance, interruption and harmonic distortion, are mainly occur due to the power line distribution and the customer load. So it's a given, these are the problems may come due to the electric power problems: impulse, notches, voltage sag, well and unbalance, interruption and harmonic distortion. Among these all, harmonics is a dominated electrical power problems, because that is directly relevant to the load. That means every house, every customer is the responsible to producing the harmonic problem or some kind of power quality problems. So that we are going to resolve here. So voltage based power quality problems are voltage sag, swell, interruption, flickers, notching, harmonic distortion and transient disturbance. Among these, voltage based power quality problems can be managed, but current based power quality problems directly relevant to the customers, where we have to address very. Among these two, current based power quality problems are more critical, and it is very dominated problems. Now here, reactive power compensation, voltage regulation, current harmonic compensation, and load unbalancing for three-phase system, and a neutral current compensation for a three-phase and four-wire system. So from this, all the power quality problems, harmonics having more domination because of the customers. Every customers directly dealing with the non-linear loads. Either they are having their home appliance like refrigerator, AC, fridge, washing machine, whatever the electronic or electrical components they are having in the home, that will introduce the harmonic problems, and that is directly related to the load. So because of that, the harmonic problem is more dominated among other problems. Now the problem we identified that the harmonic need to address. And what are the sources of harmonics? Harmonic sources are all the electronic equipments. You can see the traditional or classical types such as rotating machines, and reactors which will introduce the harmonic. Modern power electronic such as fluorescent lamp, static apparent arc furnace, SMPS, and so so this all we can see almost all the electric motors will generate the harmonic problems. And the switching power electronic devices like power electronic converters, it may be AC to DC, DC to AC, or rectifier circuit, inverter circuit, static work compensator. Static work compensator used for reactive power compensation. Even that also it will introduce the harmonic power. And the cyclo converter, we can see almost all the power converters it may introduce the harmonic sources. And the single phase power supply like in computer, fax machine, photocopier, UPS, TV, VCR, microwave oven, air conditioner, AC to DC and DC drives, almost all the equipments which we are having dealing the load, that is introducing the harmonic problems. And due to the harmonic problems we are paying more electricity, that is the common. And malfunctioning and failure of electronic components, electric motors. So we are having the home appliance, most of the motors it will, they are giving the 5 years. Nowadays is coming with a 10 years compressor guarantee. And however, if you want to increase the lifetime of the components, the electronic components, then we should avoid the we should address the harmonic problems. And second, overloading and overheating of distribution transformer and neutral conductor, electromagnetic interference in high frequency communication system like television, radio communication, telephone system. These are the similar signal conditioning devices that may affect. So sometimes we can see, but nowadays we are improved the television because we are using LCD or LED television. But earlier time, sometimes we will get the some white color distortion. Radio also sometimes we will get only some kind of noise signal rather than the high frequency or high pitch of the voice signal. So that type of problems may come in the electronic components. And a higher power cost that we need to pay like electricity bill. For home appliance we are using limited components, but in the industries, almost many industries they are having their own transformer and own. Nowadays they are starting to fabricate their whatever the power they need, they are fabricating by themselves using renewable energy system, or they are having some steam turbine where they are using either diesel or gas or even the gold mining. They are making most of the companies where their own product, but it's still that is the heavy electro industries. But most of the IT companies they are depending on the power from the government or private sector. And as we know, either central or state government which is producing the power, the equal amount of the power producing by the private sector. That means both are having the equal contribution. So now excessive measurement error in metering equipments. So these are the problem may we are having due to the harmonics. And this is not just recently, from the since 1920s. 1920s, that means before 1920s, that time even the diode only invented, even not the transistor in the practical appliance. So it is a very early concept. The harmonics are observed in the power system, limits on the magnitude of the harmonic currents and voltages. So they come up with a three standard. One is the European denormalization electrode technique, where the, and second International Electrotechnical Commission and the Institute of Electrical and Electronics Engineering IEEE. So they come up with 512 some standard. So we need to follow the standard. If any equipments that only the limited voltage and the current harmonics are allowed, that is should be less than 5%. So that we will discuss what is this standard it's given in the upcoming slide. Now here we can understand from this slide. Now it's from this study we can understand our aim is to find out the solution for these harmonic problems. We have number of solution is available. So that are the solutions here. either passive filter based solution, active filter like shunt or series active filter, then hybrid filters where both can be combined, passive and active components, and the unified power quality conditioner where the both series and shunt active filters can be combined together to mitigate current and voltage harmonics. Now from this slide, we need to find out in which is the best solution, available solution among the all. Now we need to use our intelligence, select the best in terms of money, easy to implement and cost. Second, which is the dominated problems that should be optimized. So here you can see the passive filters, we can use it either shunt or series or combine both, that will create the hybrid power system, passive filter. But the problem is we need to have third order harmonics, then we need to connect one shunt filter, that is the, you can say either capacitor or inductor. Here mostly inductor is used, or capacitor we can, or LC components are used. But every fifth order harmonics, seventh order, every order of harmonics we need individual passive circuits, that is the cost effective or again bulk in size. And the second, we have the active filter shunt or series connection. Shunt filter mostly suitable for current harmonic compensation, series filter mostly suitable for voltage harmonic problems. Now voltage harmonic problems may come from the distributor side, and as we know, as a distributor they are some give the quality of the power, because when we are startup any company, even we are anything, we are startup any techniques, so our customer satisfaction is most important, and whatever the quality we never sacrifice, so we need to give the quality is our first concern. So here the quality of, if you look at either current harmonics or voltage harmonics, 90% current harmonics problem only, because that is relevant to directly to the load. So now the shunt is the suitable. Now hybrid filter also is used, shunt active filter with the shunt passive, then shunt active filter with the series passive, similarly series active filter to the series passive. So here this combination suitable for some kind of application. Suppose you are in some difficult situation, some difficult situation, it may be some rural place where the distributor itself or the power we are consuming, that we are not getting the regulated power. Earlier time, as we are all evidence, where we have the first time the television 20 years back, we need to purchase the booster or regulator. So the television regulator is compulsory, but nowadays we are using LCD or LED display of the television, so there is no need to purchase the regulator. Even nowadays not recommended to the regulator is compulsory, but earlier time we used the regulator because the electricity always fluctuating. Even all the houses are switch on their lights in the evening time, some fluctuation may come, but nowadays that and all I didn't see last almost 10 years. But earlier time we have that type of problems where the some fluctuations may come because of the heavy load. So in that case we can use the hybrid filter or unified power quality line conditioner, both shunt and series are connected. Here as per you can decide which is the best option, so this I am giving to you only. So among these many solutions are available to mitigate the harmonics as per the, which is easy to implement because we need to make some prototype model. Second, which type of harmonics are coming, either voltage based harmonics or current based harmonics. Again, it is the higher order harmonics or lower order harmonics which is dominating of the micro harmonic problems. Based on that you can come up with the solution. As per my studies experience, I selected the shunt active power filter because the shunt active power filter mitigate the current harmonics. The current harmonics is directly related with the load, different kind of loads which we are using in our home appliance or the industrial small scale industrial appliance. almost everything is coming because of the current harmonics. My main objective to mitigate the current harmonics. So among these all the solution, I will take the shunt active filter. Now, why I selected the shunt active power filter? Because the harmonics induces several issues. Increase the heating in the transformer, low power factor, over voltage by resonance, harmonic voltage drop across the network impedance, and poor utilization of power distribution plant. Also affect the other load connected at the same point of common coupling. Suppose one house they are using, there are running some oil mills like in our home appliance they are using some, many houses are there. Some house they may be having rice mill type some that rice mill also they are not having the three phases, so some many motors are running with the single phase, and they are also connected with the same transform which we are having the home appliance. And even the oil, mm, coconut oil or some oil they will generate that type of motor, they're having the machines, so that also single phase machines they're having, and that is connected. So at that time, that type of, because of that type of load which we connected the same line to our home load may be affected. That is the points that will affect the other load connected at the same point of common coupling. Traditionally, passive filters have been used to compensate the harmonics. However, it has several shortcomings like aging, tuning problems. So 5 years once you need to change the passive filter because of the aging problem, and the resonance that may be affect the stability of the power system, and bulk in size also fixed compensation. Suppose third order harmonics I need to fix separately one filter, and fifth order harmonic separate filter. And to solve this all the problem overcome, we have different configuration like static work compensator have been proposed. Unfortunately, some of the static work compensator generate the low order harmonic themselves, and the response time of the SVC may be too long to acceptable for fast fluctuating load. So the load is fluctuating means its response time is very poor in terms of static work compensator. That's why active power filter or active power line conditioners are developed for compensating the harmonics as well as the reactive power simultaneously. The APLC topology can be connected in series or in shunt, and a combination of both, as well as the hybrid configuration. However, the shunt active power filter is most commonly used than the series, because APLs, because most of the industrial, commercial, and domestic application need current harmonic compensation because of our load which we are using in our home appliance. Now, how to design the shunt active power filter? This is the question mark. Now we decided what is the problems related to the power quality. The harmonic is the main problem. And how to overcome the harmonic problem? It's having voltage harmonic and current harmonic. Among that, which is the domination, and what are the possible solution is available already. And from that, we can come up with the shunt active power filter, because most of the loads generating the current harmonic. So to compensate the current harmonic, shunt APLC is the best option or solution. Now, how to design? It is already conventional. AC power is the main source, which is we are getting from the sub transformer, and non-linear load that is connected in our home appliance or small scale industries, even the big industries. So non-linear loads are connected. When we are connecting the non-linear load, it will generate the current like this. You can see from this graph. The first is power supply is fine, and second is the load current. So that here the load current is becoming the non-linear. Here I used the rectifier load, diode rectifier load. So because of the diode rectifier load, you can see the 6 pulse signal, which we need a sinusoidal signal. From this easily understand it's having the harmonics, higher order harmonics is available. Now you can see the currents. So IS before active power filter or active power line conditioner. If there is no active power line conditioner, then the source current also dominated by the load current, which is becoming like non-sinusoidal current. This is the big problem. So now you can see from here, if the APLC not connected, almost IL is equal to IS. That means this will affect the other customer load. That's why we need to set or connect to one active power filter at the point of common coupling. So now whatever the load is connected here, that will consume this type of current, where the whatever the load, as per the load, it will consume the power current, but the other load cannot be affected, which is connected at the same point. So that is the after active power filter, whatever the load condition, it will produce the sinusoidal, it will maintain the sinusoidal. So that is the main concept from here. Now the question is how to design this active power filter. The active power line conditioner can be constructed using the inverter concept. As we know, the inverter is a simple DC to AC converter, where almost all the places we are using inverter is the part of our life. So that inverter here used as the active filter. So that filter will produce the compensation current. You can see the compensation current to cancel the harmonics and maintain the current always sinusoidal with respect to the load current. Now, APLC compensates the current harmonics by injecting equal but opposite harmonic components. As the result, the components of harmonic current are cancelled by the effect of active power line conditioner, and the source current remains sinusoidal and in phase with respect to the voltage. Always in phase with respect to the voltage. This principle is applicable to any type of load considered as the harmonic source. Now, as we know, the engineers always need to deal every signal, every electrical signal in the mathematical form for computation or manipulation or improve the quality of the system. Now we can understand what is the source current. So from this itself we can see the source current, voltage current, that will be represented as Vs is equal to Vm sine omega m of t. And IL, from this you can see it's having the harmonics. That means IL is equal to the source current, I summation of n is equal to 1, In sine n omega t plus 5n. So here you can see the number of phase angle it may be going to change, and it's having the many numbers, the fundamental count. So I1 sine omega t plus 5 1 plus again I2 sine 2 omega, that is the omega. Now you can see here the angular frequency omega 2 pi f. So 50 hertz, 100 hertz, it will keep on increase as per the n is equal to 2. Then you can say here the 100 sine 100, and here sine 150, then 200, 250. So it's having number of order. It's having the order of harmonics. Now if we expand this one, simplify the load current, from this itself we can understand the load current. It's having three components. One is the fundamental current, which is having this one Is, and second is having the real power, and the third is having the harmonic components. So you can see the active power I1 sine omega t, and the reactive power I1 cos omega t, and the third is having the harmonics, and that also n is equal to 2 to infinity. So this is the simple mathematics form we can take here, and from this we can find out IF of t, that is the filter current. So active filter current is equal to IL minus IS of t. Now if I want to get only the source current IS, always be sinusoidal irrespective of the load. The load may be whatever the load. Irrespective of that, then I need to produce what is the IF of t. So that IF of t is nothing but the harmonic currents. So that we need to derive and make the IF of t to cancel the harmonics. And the power factor that can be maintained here, VSMs I1 sine square omega t and cos phi 1 of t is equal to Vs of t, Is of t, power p is equal to Vi, and Is is equal to, from this you can maintain Im sine omega t. This is the simple mathematics is given here, how to maintain the source current always be sinusoidal. So this is the simple only three concept you need to understand. What is the load current? What is the compensation current? What is the source current? So that also we will get it from here. So this is the current we need, active current, I sin omega t. And these are the current we need to compensate and it should be cancelled. Now, based on this simple mathematical analysis, we can design the shunt active power filter. That is a three part is important. One is the device selection. Second is the DC capacitor selection, interface inductor selection, third point, and fourth is the control unit. These are the only three things you need to consider. Now, device selection, because the source, we cannot do anything because the source is supply. And the second is the load. We need to design the active filter. First concept is the device selection. Device selection, the voltage and current rating of the device selection is based on the maximum current flow through the device. Second, the maximum voltage stress on the device during the off period and the switching frequency. These three concepts should be considered while designing or selecting the power devices. We have the IGBT, BJT, MOSFET, IGBT. So many power devices are available. Which power devices we will use? And mostly for inverter application, we will use IGBT because the switching frequency between less than 20 kilohertz frequency range. So for my application, I used 10 kilohertz frequency range. So I used the IGBT. That you have the option. You can select either IGBT or MOSFET if you are having very low power rating is less than 1 kilohertz. Then we can go for MOSFET also. MOSFET, you can increase the switching frequency. So what type of algorithm and what type of application we need to make it. So based on that, we can select the device selection is very important because that will make the cost effectiveness. This is the main part. And second, how you are going to operate, what is the power rating of the application. So that is will decide. And second, interface inductor selection. The interface inductor should be estimated by the voltage drop across the inductor per rated current with angular frequency, because the interface inductor directly connected with the point of common coupling, or in some application we can take directly connected with the grid. So this will also act as the filter here, the interface inductor selection, and the DC bus capacitor selection, because here we are not using any DC sources. We are using the capacitor to act as the source of the inverter. So the design of the DC capacitor is based on the principle of instantaneous power flow. The selection of the inverter can be governed by reducing the voltage ripple. The DC capacitor can be found from rated active filter current and a peak-to-peak voltage ripple. So DC bus capacitor selection, that is, we can approximately say, suppose we are working for the single phase, then the power supply is 230 volt. If it is 230 volt, then we can select the DC capacitor selection, that value should be 1.7% time more than the supply voltage. That is a simple concept. If you go through the DC capacitor selection, many mathematical analyses are given in the textbook or in the research paper. So from that we can select, and mostly the general rule is 1.7 times should be greater than the source supply. Then fourth is the control unit. The control unit contains the reference current extraction method and the PWM current control techniques. So two part will be there. First part is the reference current extraction technique, and the second is the PWM current control techniques to drive the inverter or the switching of the device. So these are the control unit, and we will write it either DSP processor or microcontroller embedded system. Anything we can use as the control part. So these are the four things we need to be very aware of this. And suppose you are the electrical engineer and you are very interested to introduce new topology or the circuit configuration, then you can come up with a new topology. That is based on the device selection part. And this third part, you are having the control part, fourth part. So the control, you can propose some new novel control algorithm to extract the reference current from the distorted load current, or to extract the compensation current, or to produce the compensation current to cancel the harmonics. So that is the one part, reference current extraction, or generate the compensation current to cancel the harmonic currents at the point of common coupling. And the second part is the PWM, current control techniques to drive the power converter. So these are the two control techniques you can propose and come up with. And these are some inverter topologies we can work out. And in recent time, you can see many research articles coming with different kind of topologies they are using to mitigate the harmonics. Even the same topic, they may come up with the structural topology like central type string, module type multi-ring string, and the transformerless like a zero state decoupling, zero state midpoint clamped, then solidified clamped circuits, and here multi-level topology like a diode clamped, flying capacitor, cascaded H bridge. So we can work out any kind of inverter, we can use it for this application. And the DC to DC power converter, we have either current source based or voltage based. And in the voltage based, we can have the two questions, whether I will select the current source or voltage source. So I selected the voltage source because of easy to design. Again, the current source, you need to use the transformer, and it is very compared to voltage source, current source is difficult to design. And yes, if it is easy to, we can come up, we have every problem having the number of solution. We will always see which is the easiest and the best solution in terms of economic and the quality. So here the voltage source is fine and for this particular problem. And here we have two types, and almost voltage sources based the inverter or voltage source based PWM inverter is more popular than the current source. Then the voltage source, multi-level inverter or two-level voltage source inverter, we can come up. And here I used for my research a two-level voltage source inverter, which is the conventional one. And a multi-level inverter also we can come up with a single or multiple DC source, that is the neutral point clamper, flying capacitor, cascaded H source, unequal DC source. So if you look at it today, the papers, many researchers are, they will come up with a neutral point clamper circuit, flying capacitor based inverter, and cascaded hybrid the H source inverter. So we can come up with and propose, because our job need to find out something new from the existing, then only we can be as the researcher. So that is up to your interest, because we cannot make more stress doing the research, which is very easy for us. Whether we are, because from that is we will start from our childhood onwards, when we are playing the games, doing some novelty things. Some time we are very much interested to mathematic analysis, then we can go for the programming level. Suppose you are very much interested to construct something new, then you can go for the topology. So these all we can come up with a new topology by working the existing topology, by adjusting or modifying one or two switching operation. We can come up with a new topology. Now this is the simple concept is given here, the distribution system or the power supply, then connected with a nonlinear load. This is the coupling inductor at the point of common coupling. So renewable energy sources like the solar panel can be used here. From that we can generate the DC bus, that is the, we connected with capacitor, that is the VDC. So that is will provide the sufficient power to operate the inverter. So then it will produce the compensation current. So here the normal inverter, it will produce DC to AC signal conversion. But here we are using the DC power source, but it will produce harmonic current, not the sinusoidal current. It will produce the harmonic components. So that is the only difference here. So DC to AC be as a voltage source inverter, and you can see here the inverter is applicable to wind energy. Suppose we are generating the wind energy directly it will give the AC power. However, that AC power we are just making the rectifier. Again, the rectifier it's come up with a DC to AC inverter to connect it with the grid. Even we are using the solar panel that will produce the DC power. So then we are using the boost converter, that is the DC to DC boost or buck converter or buck boost converter. Mostly we will suitable for the boost converter where almost 20 volt power supply can be converted to almost 5 times 100 volt DC to DC converter that we can use as the power supply of the DC. Then we can convert it to the DC to AC power. So here also we are using the inverter. Now, if we are working this concept, active power line conditioner, wherever else we know DC to AC converter, AC to AC converter, we have 4 type of converter topology. Among the 4 converter topology, the best optimized solution is AC to DC, again DC to AC. For the practical, most of the appliances, mostly we can say 70% applications is following this category. So here you can see the inverter is the primary and the base component where to many places we are using almost all the renewable energy system we are using the inverter, which we need to connect with the grid. And apart from that, even to save the power, we cannot save the AC power directly. So we need to save the power. We need to convert it to the DC power. That power can be stored, and that stored power through the battery. Again, to when you make the application, we need to convert it to the DC to AC inverter. So by studying the inverter, you can cover most of the real-time applications. Now, the next topic is we will discuss about the control unit. Now, power converter, we have the number of options to propose like multiple DC source converter or multi-level inverter, two-level voltage source inverter, flying capacitor, neutral point clamper. So we have many topologies already presented and well equipped. So from that you can modify or propose something new topology. And the second part, you can propose something new in the control part. That is the 2 type of controls should be adopted. One is the reference current extraction technique, another is the PWM voltage source current controller. And this reference current extraction also called the compensation current generation. Now it's having the conventional PI controller, PID controller, fuzzy logic controller, then combination of PI with the fuzzy logic, Freisy power theory. So these 5 techniques already well known. It is well reported. And here the proposed instantaneous real power theory, it's not a new novelty or something very great. So already PQ theory is presented, and that is proposed by Akaki. So that same concept, anyhow, it is the real and reactive power, P for real and PQ theory for reactive power. Reactive power is not contribute any significant power. So I consider the reactive power is equal to 0. Then only based on the real power, this algorithm is developed. That means it will minimize the number of steps by considering only the real power. So that is I just proposed with the instantaneous real power theory. Once we study, very understand about the existing concept, then we can modify something from that existing. Then second is the proposed sinusoidal extraction control strategy, that also it is available. Nothing new. Only the new is here it's having 2 sections. One is the where the unregulated or unbalanced voltage supply should be regularized using positive sequence detector. So we are using the positive sequence detector plus the same concept, which is the instantaneous real-time concept is applied here. Then proposed modified SRF, that also from the existing just one part is modified, that is the unit sign vector part. So that we will discuss here. And PWM VSI current control techniques, we have triangular carrier current controller is already well known, and triangular periodic controller, space vector modulation, fixed HCC, adaptive HCC, this all already proposed and well available. And what I did, I just hybrided adaptive, proposed adaptive fuzzy hysteresis current controller. So here I just used the fuzzy because otherwise the supervisor or the scientific people won't accept until we say that we modified something new. It's like a fruit mixture, preparing the fruit mixture. Whatever the fruits are available in the very cheap rate, we will pick up, and we from that we need to make it. So similarly, I made it here. So it is not a new, very miracle things. It's very simple. I just incorporated one more algorithm here. So that is definitely it will be need to manipulate how we will work. For that only under studying is very important. As per my knowledge, 70% of studies to become the best researcher. Now study of PI and PID controller. We can see here two part is given. One is the we need to maintain the DC power supply always constant, then only inverter can work or the active power filter will work. And we are using here the VDC reference, and that is given to KPK KD. That value selection is very difficult, and if you are having number of mathematical operation, even the textbook also available, KPID controller. So how to select KPKID, many algorithms are many formulas are there based on this active power filter design. And I selected based on the formula some value. So after that, I every time I think that is given the correct solution. So otherwise, a trial and error method or linguistic method, you can use it. What is the value KPK KD, and that will just maximize the IM. I maximize the value, so that will give the constant limiter value. We can use it. And VSA VSP VSA3 sensor used to operate the unit sign vector, which will produce the unit sign vector, and multiplied this Imax, it will produce the reference current ISC ISB ISC. So this is the reference currents are generated. And study second is the study of fuzzy logic controller. So the fuzzy logic also very simple. It's taken only one concept, the deep. So here instead of this part, I want to generate the I maximize current. So that I maximize current we have is here two, one is the error current, and here the change in error current. So the error current, change in error current sent to the falsification, and the falsification rules where the real world real numbering system converted to the fuzzy numbering, and from that fuzzy numbering it will go here. This one arrow line is missing. So that is the rule elevator. It will go to the rule elevator, and the rule elevator is based on the database. How we are under rule base, we are used here 49 rules. So change error signal and change in error signal. I taken here negative big, negative small, negative medium, negative small, 0, then positive small, positive medium, positive big. So total 7 rules, 7 cross 7, 49 rule I used it here based on the under operation. Then we got the defalsification, or again the crisp value converted to the real value, that I max value. That I max value multiplied with the unit sign vector to get the ISC ISB ISC. So here this is the second concept, PA with the fuzzy logic controller. So in that case I used the PA controller. After the PA controller output given to the fuzzy logic controller, this is also mixed one, like a hybrid. We are combined like a two filters. Suppose we are preparing the tea. To prepare the tea, we need to have the filter. Two type of filter, three type of filters nowadays available. So many places, even the water purifier also, they are having 3 layers of filters. So similarly here, first I use the PA controller to make the IMAX is fine. And that same value again went to the physiologic controller to improve the Imax value, which is having finally steady value. So from that multiplied with the unit sign vector output to generate the reference current. Now here I used the 25 rules. Again we can use 49 rules, 25 rules, 3 cross 3 9 rules, and 2 cross 2 4 rules also they are using, and they are making the fuzzy logic in very efficient manner. So this is up to you if that is based on the application. So here the 5 rule, 5 cross 5 25 rules are, and 4 cross 4 16 rules. I tried up to 16 rules, but 16 rules I didn't get the satisfied result. So I limited up to 5 cross 5 rules. Now study of Price power theory algorithm. This is already well reported algorithm, nothing new. So here you can see ILA, ILB, ILC, VSA, VSP, VSC, and VDC. Total 7 sensor we need. 7 sensor like load current, load and voltage source it's taken. And from this we are generated here the ISC, ISB, ISC. So just generated the reference current from this algorithm. And the next one proposed instantaneous real power theory, where it is already derived or deduced from the conventional PQ theory. The alpha beta coordinates, here you can see the alpha beta coordinates of the current are calculated from the V alpha and V beta with real power P, and here reactive power, real power P, this one. So here you can see we are to generate the alpha and alpha I beta current, we are used here 1 divided by V alpha whole square, V beta whole square, and here V alpha, V beta, they are like a matrix form, and P and Q is taken as 0. Here the reactive power is considered as 0 because the reactive power anyhow it's not going to contribute any important or significant power. So that's why it's simply in the conventional they are using here the P and Q two equation they need to calculate, and here I completely make the Q part it's neglected, and I made the comparison both whether PQ theory as well as only the P theory or real power theory. And the real power theory it's almost giving the same power or excellent. So that's why we can say this is the modified one, which is giving the less computation. And if it is computation less means the hardware components will be reduced, because suppose you want to make the ASIC design flow application specific integrated circuit for this. In that case, it will reduce the components. If it is reducing the components, then power saving will be there, and the increase the speed of the performance of the processor. So that will be the advantage. And again, sinusoidal extraction controller. So here in the sinusoidal extraction controller having two parts. One is the positive sequence voltage detector. Only this is the new part, and this all is based on the same which we taken from this part only. So this part is connected here, only the real power, instantaneous real power theory, plus positive sequence detector. Suppose here we are having the unbalanced or unregulated supply voltage, unregulated or unbalanced supply voltage. In that case, we can use the positive sequence detector. So to produce the regulated power supply. So in that case we are using here. And other part here also the Q power is considered as 0. So we are generated the ISC, ISB, ISC, that means a reference current extraction. And this is the modified sinusoidal signal. And in the modified, only one thing is added here, that is the simplified unit vector generation. So the unit vector generation for vector orientation for sin theta and cos theta. And the DC link capacitor voltage regulator, here we are using like a PA controller as the normal. So the DC link capacitor voltage regulator and stationary rotating synchronous frame to extract the reference current. So this part here also A, B, C, they use it DQ directly. So I used it here alpha, beta. Then again from alpha, beta current two components to the DC components we are generated here. Here the real and reactive power. So that is again is a summation of this generating the alpha beta from alpha beta to ABC. So this is already compared with the conventional SRF method, and this is really improved compared to the conventional SRF method because here two concept is introduced. One is the simplified unit vector generation for vector orientation. We can avoid the PLL circuit, but in conventional they are using the PLL circuit. Here no need to use the PLL, and here also whether we are connected here the via ILA, ILB, ILC. From that we can generate the source current, which is the reference current can be extracted. Now triangular carrier. So this is the up to till we discussed about how to generate the reference current. Now how to generate the switching pulse. That is the we are having different kind of switching pulse like a triangular carrier current controller, triangular periodical current controller, hysteresis current controller, adaptive hysteresis, adaptive fuzzy hysteresis. So these are the control we are going to discuss. And here it's very simple. It's nothing new. Now we have the generated the reference current. ISA it's showing here only one switching pulse, that is a S1 and S2. ISA it's having the reference current generated from the algorithm, and the ISA is the actual reference current sensed and compared these both and connected with a proportional constant which will given again here the triangular power supply is given. The error current, that is the reference current compared with the actual source current. The reference current generated from the algorithm with a different kind of methods like PA, PAD, fuzzy. Then we compare with the actual current source. Then it is amplified with a proportional gain. The output error signal is compared with the triangular carrier signal to generate the required switching pulse to drive the inverter. Now, second, if the current error signal is greater than the triangular carrier signal, the upper inverter is on. However, if the current error signal is smaller than the triangular signal, then the lower inverter switch is on. So this is how the switching performance will happen. And the same method for triangular periodical current controller, it's almost similar. But one thing we are introducing here, this is we are using another one clock signal. We are applying the clock signal. Based on the clock signal, the data will be generated. The error current is multiplied with the proportional gain and compared with the triangular carrier signal. And this pulse here also it is generating the pulse only. So that pulse, and here we are having the clock pulse. So then the output signal is comparator is sampled and held the D latch at a regular interval synchronized with the clock frequency. So from this it will generate the clock. So to make the clock frequencies higher, then we can use this method. But I maintain continuously whatever the techniques at 10 kilohertz and all the method. And the next is the space vector modulation algorithm is the controlled of PWM voltage source inverter. So this is also in the textbook also it's given here. How to design this algorithm. You can see just the inverter is given here. And we are having 6 phase V1, V2, V3, V4, V5, V6. So how it will be changing here, you can see 1, 1, 1. So based on this, we just made it. If A plus is on, then A minus is off, and vice versa. So V0 through V7 with the 6 active switching vectors and 2 zero vectors. So this is the dot 0 vectors. We can write V0 111 and V7 both are 111. And this is the next is adaptive hysteresis current control. This is proposed by Bimal K. Bose. So he is written the textbook also for power electronics that is translated to more than 17 languages. So he is the first person introduced this concept, adaptive hysteresis current controller techniques for voltage fed PWM inverter. So that concept is taken here. Here the hysteresis band width that can be obtained by 0.25. So point is missing, 0.25 VDC divided by FCL 1 minus L square VDC whole square VSM L divided plus M. So using this derivation, we can give the hysteresis band can be varied. And this is the error signal compared with the ISA and ISA star reference current generated and the actual current. From this, we can generate the signal. Now you can see from this easily. So this hysteresis band can be vary. That's why it is adjustable automatically as per the load changes or the inverter configuration. It will be the hysteresis band can be adaptive level. So the earlier time fixed hysteresis, suppose the hysteresis band value is 0.7 or 0.6, we cannot change it while running the motor or while running with the system. That is the fixed hysteresis. But here the adaptive hysteresis where the hysteresis value of 0.6 or 0.7 up to 0.8, it can be vary to improve the quality performance of the switching pulse. Now you can see here the adaptive fuzzy hysteresis current controller. The same, I used here the same mathematical equation, this one, the adaptive to get this HP value. That HP value again taken to the hysteresis fuzzy. Now that you can say adaptive fuzzy hysteresis bandwidth calculation. Here I used 25 rules, 5 cross 5. So to get the HP value, and that is we can see how it is improved. And now the simulation of shunt active power filter. So
sir,
still,
if
yes, sir.
If any break is required, we can take a break also, sir. No issue, sir.
What?
No, if you want any break or like that, as per your convenience, we can continue, sir.
No, we can continue. Are you getting any boring?
No. It is not like that, sir. No, it is not like that. Very interestingly,
okay,
it is.
Sir, we will continue, sir.
Okay, sir. Thank you.
Now here we are going for the simulation of shunt active power line conditioner. So here I want to say, basically I am electronics student. My MTech is VLSI design. I joined NIT Rourkela as a research scholar. My supervisor called me, are you having any idea about your research? I said, sir, I don't know what is research. I am joining this institute because of the stipend. Because I am getting the salary 15,000 outside, and the same salary here also I am getting 14,000. That's why I came and joined. And I will be here 4 years. Okay then. So then he given the title, your title is active power filter. Is your research title, whether you will work in that. Okay, fine, sir. So I filled the application, everything is given. Based on that, I taken the coursework. One is the embedded system, and another is the power electronics. So, but fortunately, the power electronics faculty didn't teach any lecture. So just he will give the questions and we need to fill it and give it. So something is went. Somehow I cleared the exams. Only 2 subjects I studied. After that, a comprehensive examination. So in the comprehensive examination, they asked multiple questions about power electronics. I said, sir, power electronics is not my domain. So you will ask a question from VLSI or simple electronic devices and circuits. Okay. Then they asked just draw the active power filter. Sir, I just using one amplifier. I drawn the circuit, the which I know. That is the amplifier circuit. Is we studied EDC. They laughed and said no. Active power filter. The word power filter. So it is a different domain. So somehow it's a full harassment. After that, I got failed. So next 40 days they given the time. I need to study and understand the shunt active power filter. Then only I realized it is completely different than the normal filter, which I thought I know only the passive filter, like low pass filter, high pass filter, band pass filter, band elimination filter, some chip by chip filter we studied in the DSP for the signal processing application. I thought like that is 6 months passed. Now within 40 days, I need to come up with what is the shunt active power filter. So I started to reading. That time I studied almost 14 hours per day. So within 40 days, yes, over. Yes, somehow I managed and my comprehensive examination over. After 6 months, I need to prepare, give the state of art. So I started to reading. Then first time I'm reading the electrical papers. Then I understand it is completely electrical domain. But however, I started to do first the 6 month I didn't see the computer. Even I didn't touch the computer to see newspaper or anything. Only studying the article papers. So almost 40 to 50 papers I studied that time. Some of the papers I studied many times and been seeing some of the papers. Mostly I followed the Indian papers, Jain, and they are given very clear concept. Then after I got a full idea, then I understand one concept of what is the research. So now I will tell here the tips or formula for research is a simple 5A. If you know the formula for research, then anyone can do at any domain. But we need to just dedicate. The first A is absolute understanding. Whatever the topic we are taken for our research field, we should study A to Z. Knowing everything is not enough. Knowing one thing about everything. So we will say 40 subject we may be studied in our BTech, 20 subject may be studied in the MTech. It is reduced to half of the subject. Now in the PhD, only one we need to study. So that means you can say knowing something about everything. Knowing something about everything that won't make any significant impact. Knowing one thing about everything is called research. So I forget everything, what is electronics, what is VLSI, everything, leave it. Because once we learn it, at anyhow we can capture it. Now one thing, knowing one thing about everything is called research. So I know how to, I started to reading all the concept where we can work actually as a from electronic domain. So I selected two places we can work. One is the power converter. We can propose some new topology. Second part is controller part. Even in the controller also we have two domain. Any one place we can work out. So I decided to work out in the controller domain. Now it's very clear. So that is the absolute understanding. So here the misunderstanding is having many place. The same I also having the examples when I was studying the 6th standard. My teacher asked in the chemistry science, write the water molecule. It is the 2 mark question. I written the water molecule. Then after the correction, the teacher distributed the answer sheet. When I taken my answer sheet and I am seeing it is the, I didn't get the mark for what is the molecule for water. I written correctly. I went and asked to my teacher, teacher, I written correctly, but you didn't give the mark for this answer. This. So it is the 2 mark question. Then madam asked me, what is the molecule for water? I said H2O. Correct. But what you written in your answer sheet? I written correct only, na? But what I written H I J K L M N O, just alphabetic letter. But when I am saying it is correct, H2O, but my understanding is wrong. I thought H2O means we need to write the alphabetic letter from H to O. I didn't understand it is the two hydrogen molecule and one oxygen atom we need to write in the format. So that presentation is I failed. So that I learned it from that concept. So we should understand anything very absolute manner. Once we understood absolute manner, the second Q for A for ask question. First, absolute understand. If you are really the engineer or the researcher, you should ask a question. If you fail to ask a question, we cannot further do the research. And asking question, two type of question. One is the standard question. Already number of solution is available. Still, as engineer, we should make one more solution because it's not a science or mathematics. This mathematics having every problem has the only one solution in the mathematics, but engineering having for one question, one problem, we are having number of solution. Even in the classroom, we tell to our student, for one problem, everyone will come up with a different solution. That is the beauty of engineering. So the second, we need to give the answer the question. That is the standard question. Second is the after the literature study, the absolute understanding, we can ask the new question. The question itself, which nobody will ask it. So if we are asking that type of question, it is mostly select in the funded research project. We can apply and we will get the funded research project. And probably as per my experience, 90% of people, more than 90% of researchers are doing the standard question and giving the modified or changed or proposed algorithm, comparing with the existing algorithm. That is the standard which 90% of researchers we are doing the practice. Even I am coming that category only. Standard question, but something new answer. But another is the answer itself new. That is the really new concept, and based on that only many inventions are happen. When the first time Newton asked a question, why apple falling down? Why all the objects are falling down towards the earth? He asked to the school teacher, he asked to the many friends, and he asked many person, nobody given the answer. Finally, he find out by himself the answer, that is the force of attraction. Even so, Wright brothers, where they studied the ITI, that time they asked, we also want to make the machine where we can fly like a birds. Everyone said, no, it's not possible. But they didn't get the answer from anyone, but they modified this design, the motor design, and they made the wings, and one day they flight. So if you ask the questions based on the literature review, and that answer you only can give, and whatever the answer you given, it will take some years to realize the others. So that is the two way of only standard question and new question. That is the first A for absolute understanding, second A for ask question, and the third A for answer those questions. Nowadays, we are very, some of the school children are very eager to ask a question, but they don't think how to answer those questions. Now, asking question also, we need to answer those questions. That is the talent of engineers. We need to answer those questions. That is the third A. And the fourth A, attempt to implement those questions, answers, which we are given the answer, that who will going to implement? We need to implement. So whatever the answer we proposed, whatever the hypothetical answers we filled, that answer we need to implement it. We need to experiment it. So that is the fourth A, attempt to implement those answers given by us. And the fifth A, acquire the conclusion or justification about our work, which is maybe comparison with the existing or the proposed algorithm or proposed topology or concept. Somehow you need to come to the acquire the conclusion or justification. These are the 5A to become the research. So still my research, I completed 3A. The first one, I understand what is the active power filter and what is where I need to work, what is the harmonic problems should be mitigated. Among the harmonic, what are the techniques are available, among that which is the best one, I selected that part. And the second A, ask a question. So yes, I asked what are the already techniques are available. So I seen Akaki produced PQ theory and SR theory, PQ theory and real power, real and reactive power theory, then Pricey power theory, PA controller, fuzzy, everything is available. Still, what I can make it? So I can make like a hybrid fruit mixture. So I did, and that is the answer question. And again, what type of converter even here I discussed about the current converter. Current converter itself having two types of current converter. If we study the literature review, it's having direct current control techniques, indirect current control techniques. In the direct current control techniques, we need to use the harmonic current should be sensed. The harmonic current should be sensed. That is ICI, ICB and IF or IFE, IFB, IFC. Then from that we can generate the reference current. That is the direct approach. And the indirect approach, whatever the compensation current, we don't bother about that. We will take either source current or load current because that is always common. So that is the indirect approach. And if you are using indirect approach, we can reduce the number of sensor, at least 3 sensor we can reduce it. So here I used the indirect current control techniques. So that is the we can say the questions will be asked which I need to select, the device selection, what type of DC capacitor, either it is the single phase or 3-phase system, and if it is the PWM current controller, which type of current controller, either it is the current based or voltage based. If it is the voltage based, again, what is the techniques, either direct current control techniques or indirect current control techniques. So it's having number of options. Among that, I need to select the best for my, it is easy to me, and it's also give the optimized solution. So that is the asking question. That is attempt to answer those questions. Already many question answers available. So I also given that answer. Now fourth one A is I need to implement those answers. Attempt to implement those answers. So for that I taken this implementation process using the first MATLAB Simulink model, where I taken the supply voltage frequency 415 and the smoothing inductor diode rectifier for the load, and interface inductor DC side capacitance. It's taken 2200 microfarad because I need to maintain 1.7. That means almost 700 volt to perform this active filter, and the reference voltage and voltage source inverter is 6 IGBT is taken here. So this is the simple concept is given here, where the 3-phase supply voltage, there is nothing new here, and the load we can distribute here the rectifier load. So non-linear load is made it here, and we can take here the 3-phase supply voltage. We are taken VSA, VSB, VSC, and here ISC, ISB, ISC. Then we are having, so this particular algorithm I use only 6 sensor plus 1 sensor, that is a VDC reference VDC. So only 7 sensor used here, and some algorithm we need to use the 9 sensor. And if we are going direct current techniques, then we need to use this IFE, IFP, IFC also need to take. So it will, if we are going indirect current control techniques, we can reduce the components. So that is the unit current vector, and UC is BUC. So the reference current generation. So we are generated the reference current ISC, ISB, ISC, and this algorithm is applicable PI controller, PID, fuzzy logic, and PI FLC. So the same kind of setup applicable to other techniques also, like instantaneous real power theory, Pricey power theory, sinusoidal reference current extraction theory, modified SRF theory. So that to generate the reference current. After generating a reference current, we have the triangular carrier current controller, triangular pulse carrier current controller, SVM techniques, fixed HCC, adaptive hysteresis current controller or adaptive passive hysteresis current controller. Any one of the techniques we can use it here. Any one of the technique we can use it and to generate the switching pulse to drive the inverter. So here the VDC we didn't take any. Nowadays the recent paper which they are connecting the solar panel to get this voltage should be supplied. So we can use that also. Instead of here we can connect one solar panel and we can run it. And it will operate in the 3 mode. The first mode A, where suppose this is the off condition, because in the initial stage when we are connected to the load, it will be off condition. So that time, what the power supply voltage, this is because we are connected here the IGBT with the diode, it acts as the rectifier. The first mode 1, so it is having the 3 mode of operation, mode 1, mode 2, mode 3. So mode 1, you can say the supply voltage is greater than the inverter power supply, that is the CVDC or VDC, you can write it here. The VDC voltage is lesser than the power supply. Here suppose you are taking 415 volt power supply, 415 volt AC power supply, and here it is less than that because initially the capacitance value is very less, or it may be 0 also. So under that condition, mode 1, where the supply voltage is greater than the VDC, it will act as the rectifier to recharge the supply. So when it is charged to, now the second case mode 2, where mode 2 is having 2 conditions. VDC is greater than supply voltage. Under this, it will compensate the current or it will observe the current. So 2 types, inject the current or deliver the current. So based on the requirements of the load changes. So it will act the mode 2, it may inject the harmonic currents, and mode 3, where it will deliver the compensation current as per the load changes. So that are the 3 mode of operation it will be performed here. Now this is the simulation waveform for fuzzy logic controller is taken for the example. You can see the supply voltage, and the second is the load current, ILA, it is the load current. And when the active power filter is off condition, that time you can see ISA, which is producing the similar to the load current, the same. But when it is the active power filter is connected, after that you can see it is producing the compensation current or the field harmonic current. So after supplying the harmonic current, then it will come the sinusoidal. Whatever the condition, it will become like a sinusoidal. So this is the simple understand. The source current after compensation, when active power filter is on, when the active power filter is on, then you can see this will be coming sinusoidal. Now DC capacitor voltage settling time. So we derived almost fuzzy PID, FLC and PIFLC. So here PIFLC, it is you can see how the settling time will be reduced, because once it is having the less settling time, then it will give, there is no fluctuation. Here you can see some fluctuation, but it is very small minutes, 0.4 to 0.5, or you can take 0.6. So it is not even maybe 0.02 second delays will be there, the fluctuation. So when we are settling time, once it is become the constant, then it will produce the correct otherwise some fluctuation will be there. So that is the how much seconds is taking to settling time. And this is the active power filter total harmonic distortion measured without active power filter, with the active power filter. And with the active power filter, you can see it is reduced to 3.47. And this is the another load steady state and transient state. We are taken to state of order harmonics. And here we are getting the voltage source per voltage current that maintain the unity power factor. That is the harmonic current compensation can be achieved when we are doing. Actually, our main objective to reduce the harmonics. While doing the harmonics, actually we are getting like a bonus. So nowadays that is the common the bonus which we are getting something we will get some discount. So this we are getting like a bonus. It will maintain the compensate the reactive power to maintain the unity power factor. That is also we are getting here. And this is the total harmonic distortion. I used two type of rectifier load, diode and thyristor based rectifier load, and compared with the steady state and transient condition with a different control algorithm, and measured the without active power filter and with active power filter what is the HCC value. But anyhow, it is not too variation among all the techniques. And similarly, real and reactive power also measured here for the two type of load, diode and thyristor rectifier load for the different control algorithm. And the here I used it with HCC, adaptive HCC and adaptive HCC. So here we have number of options to make. And part 3, as we are the electrical domain, we need to make it some at least the prototype model. And this is the prototype model which is made. The experimental setup is prepared and validated for 3-phase active power line conditional system. For hardware implementation, I chosen the modified SRF theorem with SVM, and both adaptive fuzzy hysteresis current controller is demonstrated, because that time the this algorithm mostly I simulated using Simulink model, and I had the full complete mathematics, which is written the step by step. But this algorithm written by the BTech engineers, where they worked in that company, Industrial Drives Private Limited. So they written assembly language. This program completely written in the assembly language on running. So this is the parameter and simulated values and experiment values which I used. Simulated values as well as the experiment values are given. So the voltage source inverter, I used the IGBT module, and this is the gate driver circuit, and the sensor I used here LP20P base voltage and current transducer, and for the DC link voltage and Texas processor I used a TMS 320F 240 DSP processor. Now this is the setup. So this is the we made it. They also cooperated very nicely, because after my BTech I was working this company 6 months. So that link I went to my PhD also. It is developed in Chennai. Even if you search in internet now, they are not having this operation. So this we tested in the Hyundai car company also. But after 6 months, it is given some problem. So that time they called me, but I am not able to reach there. And that company also left the project. So here we developed this, all developed by program written by engineers, that is their BTech that time while I am doing my PhD. So I just explained them, they written in the assembly language. And the second, it is all developed by ITI even. So 3% they worked. After 5 o'clock we developed this, because it was already there. We just assembly, we did the assembly. And this is the real-time data is taken with the modified SRF with adaptive fuzzy hysteresis current controller. So we can see here the voltage source, whatever, it's almost sinusoidal. But here ISA. So this is the ISA with the load. So I taken the ISA with the nonlinear load. You can see here it's not coming the sinusoidal. And this is a switching pulse. And here we can use compensation current or the filter current, which is delivered by the active power filter, which is made up of the inverter concept. And this is after this, we are getting almost ISA versus ILA. So here you can see this black color is that is the ISA current which is generated, and here you can see ISA off and ILA, it is separated this one. So number D, compensation current, source current after compensation, and load current and source current after compensation. You can see whatever the load condition earlier time, this is the source condition. Now the source condition now is changes the source current. So here the source current, this is the source current after compensation. Now this is the again the same three-phase I taken here, the same method. This is the source current without active power filter. Source current without active power filter. This is the source current with the active power filter. This is the compensation current or active filter current. Now this is the modified SRF with adaptive. So order of harmonics here, you can see 22.5, and the frequency almost 50 Hz frequency. And after this we got the 3.7%, and we are maintaining here. You can see the harmonics also 50 Hz, and here you can see the order of harmonics 22.5, and here it is 3.7. So without APLC and with the APLC we are taken these two readings. And this is the DC voltage power supply is maintained constant. Almost it will come 700 volt. This is the reactive power compensation. From this we can see we taken the result without active power filter and with active power filter. So this result you can see, this is the supply voltage versus the reactive load, resistive load. So resistive load, there is no problem, it is both are in phase. But when it is connected the inductive load, we are taken one inductive load, then it is having the phase shift, and that is the compensation current. When I applied the compensation current, then we can see that time after of active power filter compensation under inductive load, you can get it, this is the in phase. So that is the reactive power compensation is performed here. Now this is the DHT measurement of the DHT in simulation studies. With the experiment and the simulation studies, it's almost giving similarity result. So we modified this part, we verified this part. Now conclusion is, the project control algorithm is demonstrated through the TMS 320F 240 digital signal processor for adaptive power filter or power line conditioner application. The instant end is real power theory and adaptive fuzzy hysteresis current controller algorithm is demonstrated and implemented. No, this ISE silence. So this part also I done, but it is not included the slider here. So the total harmonic distortion of the source current is compliance with the IEEE 519 and IEC 6100003 harmonic standard. As per the harmonic standard, the acceptable current rate should be less than 5%. So this is demonstrated. And empowerment, so I just taken what are the opportunities we can do, but this is for the student. So as we are the faculty, it's difficult to practice. So if we can tell to our students, if they spend 20,000, they can make the mini lab in their home, and they can perform many type of experiments. Nowadays, many textbooks are coming with small experiment things. So when we need the breadboard, active and passive components, because our electrical or electronics engineering dealing with only 5 components. So out of 5, 3 are passive elements like resistor, capacitor, and inductor. Only 2 active components, a diode and a transistor. And in transistor also, we will get IG MOSFET is very less price. So whatever the circuit, either DC to DC or DC to AC, even amplifier circuit, filter circuit, any kind of circuit, we will use only these 5 components. For the measuring instrument, we may need some multimeter or a drilling machine to learn something to make the printed circuit board. Otherwise, only breadboard itself we can perform many experiment. Now this is also suitable for the students, where they can give electrical or electronics students can give this many exams for get the job as per the. So it's having only I given the 9, but more than many companies are given based on the GATE exam itself. We can get more than 300 jobs in public sector unit. So central public sector enterprises is having 300, Mini Ratna 74, and Maharatna is 8. So it's given the list, and list of Navratna is 16. So this all coming with we can find out once the public sector unit for engineers. Only their eligible is GATE group discussion and personal interview. Mostly many nowadays in 2006 onwards, they are taking based on the GATE score. So if the GATE score is very good, then we can join any public sector unit. And these are some references for preparing this PPT. So now it's time for discussion. Sir, if you have any queries, we will discuss, sir.
Participants, you can start your queries. Any queries you can post. If not possible to like speak, then you can post queries in the chat box also.
Hello, Professor.
Yes, sir.
Sir, Veeramudalingam, sir.
Yeah, please, sir.
Sir, I need small clarification, sir.
Yes, sir.
Small clarification about
Tell me.
controller, sir. If I am using PA controller,
yes, sir.
Sir, can you hear me, sir? Hello.
Yes, sir. PA, if we are using PA controller.
If I am using PA controller, open up TH3 is
okay,
30%, sir. If I am implementing closed loop, again I get 10% only, sir. How to reduce 10 to within the limit, sir?
10 to 15, I am not getting full the videos.
Less than 5%.
Yes, sir. Sir, please make it the chat box, sir.
Sure. Okay.
Question, please, the participants type. You type the question, sir, on the chat box.
Participants, you can post your queries. Yeah.
How to reduce the DHT with 5%, less than 5%?
Yes.
Sir, it's the whole lecture is going on how to reduce the THT with less than 5%. We are having number of control algorithms, sir. PA controller, PID, fuzzy logic controller, and a very optimized two control algorithm. One is the Agagi produced, that is the real and reactive power theory. Another is the PQ theory. So this control algorithm, if you are writing and implementing, then it is very easy to reduce the DHT less than 5%. Sir. If it is even your result is 5% of DHT, they as per the IEEE standard or IET standard, it is not applicable. You cannot publish, sir, the paper. It should be less than 5%. And in the simulation part, you can achieve up to 2.5%, sir. Even in the hardware, we got 3.7%. That is how you are writing the algorithm. Nowadays, many people are writing artificial intelligent algorithm, like neurofuzzy algorithms. I seen the recent papers. They are mostly coming with neurophysiology and deep learning algorithms to generate the reference current, and the control method is very simple here. Either you are having the direct approach or indirect approach. Direct approach, you need to generate the compensation current or the filter current to make the compensation. And the second part, indirect current control, whatever the load condition, we don't bother about. We are maintaining our sinusoidal signal is always constant, or irrespective of the load, we need to maintain our signal. The highest source current should be sinusoidal. So in that case, in the indirect approach is used. So in that, we have number of answers already available. You can also come up with a new solution, sir. So only the control algorithm you can be able to improve the or reduce the total harmonic distortion.
Okay, Professor. Thank you, Professor.
Which
Explained very well,
inductive
Professor.
load you used for your work? Sir, I used the inductive load in the company. I used one motor, sir, inductive motor. But in the experiment of the simulation link, I used just a resistive load. Yes, in testing also we used a different type of, even I used one resistive load also we taken. That is almost some millihenry resistance load we prepared, because that time they given that R&D section to me. Almost 3 months I was there in Chennai to prepare this setup. And is there any research group of your where I can connect with you? Thank you, sir. Right now research group, and now I am working in VLSI domain, sir. 2 PhDs are working in VLSI. I am not nowadays. I am not working in after 2018. I didn't work in the semiconductor. Before that, I got that 3 project that is from power electronics domain only. One is the IT power filter extension, that is from BRNS, and second I got the renewable energy system based, that is the electric vehicles. So that electric vehicles project, and now they got PhD and they are working in Hyundai car company. So what hardware is used for particularly implementing the PA and fuzzy controller? Sir, I used the hardware that is the TMS 320 F240, sir, DSP processor. We used, sir. But again, I implemented in my college while doing PhD. That time, that board, FPGA board also. We used FPGA board. Partially, I implemented the control algorithm. So we can use any processor, sir. Either FPGA processor or any DSP processor you can use to implement the control algorithm. For my application, I used the TMS 320 F240 DSP processor. Sir, any other question? Otherwise, we can wind up sir session.
Yes, sir. It's a great session. Yes, sir.
Really thanks to Muthukumaran sir who gave the opportunity to deliver, and I special thanks to all the delegates and the professors.
It is very much thanks. Thank you, sir. From your place, actually, our participants as well as myself, we are sitting in our house. But you came to for this purpose. You came to your college and you are delivering the lecture for us. So thank you so much.
Sir, we are residential campus, sir, and it's only walkable distance.
Okay. Okay.
Our institute and college both are residential institute. All the IITs and NITs are residential institute.
Oh, okay.
It's not far distance. It's
Oh.
only 800-meter walkable distance.
Okay, sir. Okay, sir. It is a very great session for us. So I think many your experience related with your PhD, definitely those things will be helpful for those who are doing the PhD, those who are currently doing the research work. It will be definitely it is a great work session for them also. So we can wind up, sir. Thank you so much. Thank you so much, sir.
Thank you, sir. Thank you. Thank you to all the participants.